In design and analysis of algorithm, today we will understand what is an algorithm. So algorithm is nothing but it is stepwise representation of procedure to solve a problem. So we will write this stepwise representation of procedure to solve a well-defined problem. And also the steps must be well defined. Problem must be well defined and step must be well defined. Steps must be well defined. So what is the meaning of well defined steps? uh, for this, take an example. Suppose we want to calculate we want to write a step to calculate average of three numbers. So we can write this step like average equal to a plus b plus c divided by 3. Here this will first add a plus b, then will add c by 3 to a plus b. So our purpose is to find the average of three numbers, so this will not solve our problem. So for this we will use parenthesis here, or we can write in this manner a plus b plus c divided by 3. Although this step is not still well defined, because here we have not defined the division operator, whether it will do the integer division or will perform floating point operations. So we can write here in comment that this division operator will do floating point division, do floating point division. So like this, we have to make the steps very unambiguous and clear. We can also have one more definition of algorithm, formal definition, which is well defined. This is first definition, and second definition we can write well defined computational procedure, which takes zero or more input and produces zero or more output for a well-defined problem. That is, here we are saying that well-defined computational procedure, because we are talking algorithm in terms of computer programming. We write the algorithm before writing the computer programs. We convert these algorithms to programs. So here we have used computational procedure which performs computations, and algorithm must take zero or more input. That is, sometimes there are algorithms which do not take any input, and sometimes they take input. That's why we are writing zero or more input, and each algorithm must produce some output. So in other words, we can say algorithm transforms input to output. That is, we can say algo transforms input to output. Now we will understand some important characteristics of an algorithm. So characteristics of algorithm. So what are some important characteristics? That is, first characteristic is input. That is, each algorithm must take some 0 or more input values. 0 or more input. Next characteristic is output. That is, algorithm must produce 0 or more output. Must produce 0 or more output. Next is finiteness. That is, each algorithm must terminate after finite number of steps. Must terminate after finite number of steps. That is, no algorithm should run indefinitely, because we cannot get the output, or we cannot define the things which are indefinite in the computer programming or in the computer system. So each algorithm the steps must run after finite number of time. Next is definiteness. That is, steps of the algorithm must be clear and unambiguous. Steps must be clear and unambiguous. We have discussed this in the definition of algorithm, that steps must be unambiguous. That is well defined. And next is effectiveness. So effectiveness step tells that steps must be basic and essential. What is meaning of this? That is, we should write the steps in the simple form. We should not write the steps like we write the complete problem in one step. So we have to break those complex problem into simpler one, and we should write only essential steps which are required, and we should not write unnecessary steps which will never execute. Next is correctness. That is, must produce correct output. Sometimes algorithm runs and produces output, but that does not matches our theoretical computed output. And next, an important characteristic is efficiency of an algorithm. This denotes runtime of efficiency is measured in two ways. One is running time, and another one is the space complexity. That is the amount of memory acquired during the runtime of the algorithm. So we are concerned only with the runtime of algorithm. Now we will understand how to write an algorithm and how to analyze the algorithm. So we can write a simple algorithm for finding maximum of a number in the given list, and numbers are stored in a given array. So for this we first store the first element of the array in a variable that is called max. Here we are taking max, and we will compare this variable with all the elements, remaining elements in the array. So here we will run for I equal to 1 to, for I is equal to 1 to n. Suppose there are n elements, this is 1, and we will compare this max with all the elements. If max is less than a of I, that is a of I, then this is the maximum number, so we will store it in max variable, max equal to a of I. And here we are using indentation. There are several ways to write an algorithm. For example, here we can write do or begin and end, or for or end for. So there are several ways to write the algorithm, but here we are using indentation. That is the statement which will run inside the for loop. We will write after leaving some space from here, and the statement which will run under if statement we will write after leaving some space from here to here. For example, so this is called indentation. So if we are using indentation, then there is no need to end this if, like end if, end for. Next we can print this. After running of this loop we will get the maximum number, and next we can print this maximum number like print max. Now we can analyze the runtime of algorithm. So for analyzing the running time of algorithm, we have to first consider cost of execution of each statement. And before writing the cost here, we will give line number to each step: 1, 2, 3, 4 and 5. There are 5 steps here, and this print statement we will comment here, because we do not consider input and output statements while calculating the running time of algorithm, as input is dependent on the user and output devices are much slower than the CPU. So we are not considering. So here we will write how many times each statement will execute during the runtime of the algorithm. So first here we are writing cost, and here we are writing number of times. Number of times each statement is executing. So this statement will execute only one time, and this statement from 1 to n, that is it will execute n plus 1 time, because from 1 to n for true values, and it will run one more time for false values. So overall it will execute n plus 1 times, and the statement inside this for loop will run one less than the for loop statement. So this comparison will execute n times, and if this is always true, then this will also execute n times. And here cost of this is, here we have written number of times, so we will change here number of times, that is cost here we are writing, and number of times we are writing here. So this will execute 0 times, because this is comment, and let the cost of this is C1, cost of this is C2, C3, C4, and this is 0, so no need to write, or you can write it C4 C5, and this will be multiplied to 0. So now we can write the complexity expression of this algorithm. So suppose there are n inputs, so complexity expression will be 1 into, or we can write C1 into 1 plus C2 into n plus 1, then C3 into n, then plus C4 into n plus 0. So this will be C1 plus C2 into n plus C2 plus C3 into n plus C4 into n. So we will segregate these terms in terms of polynomial. N is the input size, so this will be C2 plus C3 plus C4 into n plus constant C1 plus this is C2, C1 plus C2. So we can give another name to this constant, that is A into n plus B, where B equal to C1 plus C2 and A equal to C1 plus C3 plus C4. So this is linear polynomial, 1 degree polynomial, and we can write the maximum runtime which will be order of n. Later on we will study the different notations to represent the running time of the algorithm. Here we will write the maximum degree term. Like this we can compute the runtime of any algorithm.